Okay, so chapter 12, day 1. Today what we're going to focus on are what are the components of a survey. We're going to be doing some surveys, analyzing surveys, doing some surveys of our own, but we need to know what all the pieces and components are and all the vocabulary that goes with it. So the first thing we're going to talk about is population. I think you pretty much know when I say the word population, you think of a large group. But it's defined to be the entire group of people or things, because it's not always people that we're studying, that you're trying to find information about. So if you're trying to figure out the life expectancy of a tree frog, the population would be all tree frogs of that certain genetic type. If you're trying to figure out what proportion of people drive a car with their seatbelt on, well, you need to define a little bit better. Are we talking about teenagers? Are we talking about all drivers? Are we talking, what are we talking about? So the population is defined to be just the entire group that you're trying to get information about. The sample is part of the population. It is a smaller representative group. And if it's not a representative group, then it's not a good sample. So if my population might be teenagers that live in the Greece area, I might take a sample of those here at Greece Arcadia High School. You are part of the population. You're a smaller representative group, all right? And this representative group we'll talk more about, because if it's not a representative group, then we might run into bias. Bias is when your method over or underestimates a characteristic of the population, okay? You run into bias when your method over or underestimates a characteristic of the population. So for example, let's say I want to find out what proportion of students at Arcadia High School have their driver's license. My population would be students at Arcadia High School. My sample would be the kids that I select, okay? So I randomly picked a few advisements. I got 3 freshman advisements and a sophomore advisement, and I looked at those kids and I realized, hey, not a single kid has their license. Looks like no one at Arcadia has their license. Well, my method underestimated that characteristic because my method didn't allow, by randomness, I didn't even get any juniors or seniors. I should have changed my method to maybe listing only senior advisements, because that's when most kids are of the age where they could get their license. Randomization, we learned last class, helps reduce the bias. So that way we're not going out walking the halls and hand selecting the sample. Sample size. I know it is the size of the sample. It's like, sample size of the sample. But here's the most important part. It determines how well it represents the population. So if I go out and I survey only 3 people, that might not represent the population too well. But if I survey 30 people or 100 people, now it might be a better representative sample of the population. So when I talk about sample size, I'm not only defining it, which is the size of the sample, I'm also talking about a characteristic that it has, which is it'll help determine how well it represents the population. Sampling frame is the list of individuals that the sample is drawn from. Now, whether you have a physical list or you know it, that's where the sample is drawn from. So for example, again, I want to find out what proportion of high school seniors in the Greece area have their driver's license. I take a list of Arcadia students and I select from them. The Arcadia students then are my sampling frame. That's who I'm picking my sample from. And from there I might pick 30, 40, 50 Arcadia students. But the frame itself is the Arcadia kids that I'm picking from. The frame isn't always your population. My population might be all Greece high school seniors. Census. I know you've heard of census before. Census is when the sample is the entire population. So if I am surveying and my sample is everybody, then I have taken what they call a census. Now, censuses are good in certain situations, not good at others, okay? So if I want to know the average age of a teacher at Greece High School, there's only about 100 of us, I would just go out, survey everybody, and take a census. If I wanted to know the proportion of students at Arcadia High School that have a pet in their house, taking a census would be kind of tough because there's over 1,000 kids here. Census in that case would be kind of too tedious. But census is if your sample is the entire population. Now, these next two go hand in hand when we talk about them. So the first one is called a parameter. A parameter is the true value from that population. Sometimes they call it the population parameter. All right? It's the true value. Okay? I want to know what the true average height of boys are at Arcadia High School. I have no idea what that is until I would have to sample everybody or take a census and measure them. It's too tedious. But I'd like to know what the true value is, and if I could figure it out, that would be nice. But the true value is called the parameter. And the true mean of anything, which true average, mean is another word for average, we symbol with this Greek letter that looks like a U with a tail on each end, and it's pronounced mu, M-U, pronounced mu. It's not an M, it's a U with tails on each end. The true proportion we symbolize with a big capital letter P. That's the true proportion. Like, what's the true proportion of kids at Arcadia High School that own an Apple iPhone product? I have no idea what it is, but if we would like to find out, I could take a sample, and that sample could estimate the true proportion, or the population parameter, which is the true proportion. Usually this value is unknown, and we are trying to find out what the value is. And so we're always trying to estimate. Maybe estimate's a better word there than find out what this value is. So we'll try that. How about we use the eraser though? Trying to estimate what this value is. Last thing, statistic. You are in statistics. Why do they call it statistics? Because it's a process of gathering data, trying to find out information about the parameter. A statistic is a value found from data. If it comes from data, it's called a statistic. Okay? The two most common ones that we deal with would be our sample mean, which we call X bar. Okay, so if you see X bar, it means that data was taken, or that mean was taken from data. All right? And the other is a sample proportion, which is called P hat. Okay? And that means that that's the proportion taken from data. Parameter are the true values. Mu, this would be the maybe average height of boys, and this is the proportion of kids with a cell phone. Those are the true ones. I don't know what they are, so I'm going to go out, grab a sample, look at the data, and now calculate a statistic, which is X bar if I wanted to find the average. I select 10, 20, 30 boys, find their heights, take an average. Or a proportion, gather kids up and ask what proportion of you, or count how many out of total have an Apple iPhone product. Okay, so when we come back in the class, we're going to do some work with this. But that is chapter 12, day 1.